The eruption of Tonga Ha'apai was not just a visual spectacle. It was an atmospheric event of global proportions. Scientists soon realized they weren't just dealing with a geological explosion, but with something that reached into the skies and potentially into the planet's climate systems. So the question is, did the Tonga eruption actually change Earth's climate? At first glance, it seems like a strange question. Most large volcanic eruptions, like Mount Pinatubo in 1991, are known to cause global cooling. That's because they eject massive amounts of sulfur dioxide, SO2, into the stratosphere. These sulfur particles reflect sunlight, creating a temporary sunshade that cools the Earth for months or even years. But Tonga was different. NASA's satellites quickly revealed that the Tonga eruption did not release much sulfur dioxide, but it did inject an extraordinary amount of water vapor into the stratosphere. Estimates suggest that more than 146 teragrams, or 146 million tons of water, were blasted into the upper atmosphere. To put that in perspective, that's enough water to fill 58,000 Olympic-sized swimming pools, all suspended in the air above our planet. This sudden, massive surge of water vapor has never been observed before. In fact, it was the single largest increase in stratospheric water content ever recorded. And unlike sulfur dioxide, water vapor is a greenhouse gas. It traps heat instead of reflecting it. Scientists at NASA's Jet Propulsion Laboratory warned that this increase could lead to a temporary warming of the stratosphere. This might sound subtle, but it has big consequences. A warmer stratosphere can influence jet stream behavior, ozone chemistry, and even the development of extreme weather patterns across continents. So how did the water get there? The eruption's explosive force sent materials vertically at supersonic speeds, shooting well into the mesosphere, over 58 kilometers above the Earth's surface. As the steam rose, it bypassed the troposphere, where weather occurs, and entered the stratosphere directly, where water vapor can remain trapped for years. Typically, this region of the atmosphere is cold and dry, so when a sudden surge of moisture is introduced, it doesn't just disappear. It interacts with existing chemical systems, like ozone molecules, potentially altering their balance. Some scientists now fear that this excess water could lead to stratospheric ozone depletion, weakening Earth's natural UV shield. But the effects don't stop there. Climate models are now being adjusted to include this moisture anomaly. While it's unlikely that the Tonga eruption will drastically warm the entire planet, it could slightly shift global temperatures upward for a few years, a rare phenomenon for a volcanic event. That's not all. The eruption also disrupted weather patterns across the Pacific for weeks. Shifts in pressure and atmospheric dynamics created unusual storm systems, increased rainfall in some regions, and prolonged droughts in others. Meteorologists observed atmospheric waves that rippled across the globe, altering wind currents in the southern hemisphere. It's the first time in modern history that a volcanic event may have warmed the Earth's climate instead of cooling it. And that opens up an entirely new chapter in climate science. Could future eruptions like this accelerate warming trends already in motion due to human activity? Could an underwater volcano become a wild card in our climate system, unpredictable, unstoppable, and invisible until it's too late? At Infinity Beyond, we explore not just the what of science, but the what if. And in this case, what if a single eruption altered our atmosphere enough to change the balance of weather, energy, and ozone around the world? It's a sobering thought, but also a reminder that we must observe our planet more closely than ever. Because the forces that shape our future might come not from industry or cities, but from deep beneath the ocean floor. In the next segment, we'll explore how this eruption was captured by civilian cameras, sensors, and even social media, and how the digital age gave us the first truly global, crowdsourced volcanic disaster archive. Stay curious, stay informed, stay with Infinity Beyond.